Just take a look at this. I mean, really look. It's a plant, and it's eating a frog. We usually think of plants as, just sitting there. But this one, it's an active predator. So what gives a simple plant this kind of power? The ability to actually trap, kill, and then digest an entire animal? That right there is the big question we're tackling. See, like any carnivore, the Venus flytrap is getting vital nutrients from its prey. But the amazing chemical process it uses to break down that frog, well, it's powered by something incredibly common, something you and I interact with every single day of our lives. And believe it or not, the answer is water. Yep, H₂O. It seems so ordinary, but this little molecule is the secret ingredient that makes pretty much all of life, and even a plant eating a frog, possible. So today, we're going to uncover the hidden superpowers of this miracle molecule. So here's our game plan. We'll start with the molecule itself. Then we'll dig into the secret behind its powers. After that, we'll explore its amazing ability to dissolve stuff, to stabilize whole ecosystems. And we'll finish up with its absolute weirdest, most counterintuitive trick of all. Okay, let's dive right in. Section 1, the miracle molecule. It's time to properly meet the hero of our story.
So, on the surface, it's about as simple as it gets. Just one oxygen atom bonded to two little hydrogen atoms. I mean, you can't really get more basic than that, right? But this super simple structure is hiding a profound secret that gives water all of its incredible abilities.
Which brings us to Section 2, a powerful attraction. This is where we get to the real heart of why water is so special. It's not just about the atoms themselves. It's all about how they're put together. So the big secret is this. Water is what we call a polar molecule. Now, what on earth does that mean? Well, it just means the molecule isn't perfectly balanced electronically. There's a tiny, slight charge to it. And this tiny little imbalance is the source of all its strength. Here's how that charge is spread out. The big oxygen atom is kind of greedy. It hogs the electrons, which makes it slightly negative. And that leaves the two hydrogen atoms out on the end feeling slightly positive. We use that little delta symbol you see there to show that these are just partial charges, not like a full-blown ion or anything. And you know what they say, opposites attract. So the positive hydrogens of one water molecule are drawn to the negative oxygen of another one. This creates a pretty weak connection called a hydrogen bond. Now, one on its own isn't much, but when you have billions of them constantly forming and breaking, well, that's what gives water its superpowers. Okay, let's see how this all leads to our first superpower in Section 3, the universal solvent. This is water's incredible gift for pulling other substances apart. It works a bit like this. Imagine you drop something like salt into water. The charged water molecules just swarm it. The negative oxygens grab onto the positive sodium ions, and the positive hydrogens grab onto the negative chloride ions. They literally just tear the salt crystal apart, atom by atom, until it's completely gone, dissolved. And this isn't just some cool chemistry trick. This is absolutely essential for life. It's the reason our blood can carry nutrients around our bodies. It's how plants pull minerals up from the soil. And it's exactly why the chemical reactions inside that Venus flytrap can even happen in the first place. They all take place in a water-based solution. On to superpower number 2 in Section 4, life's great stabilizer. Thanks again to those amazing hydrogen bonds, water is fantastic at resisting change and can even provide physical structure. First up is something called high specific heat capacity. Now, that sounds super technical, but it's a fancy way of saying water is really, really stubborn about changing its temperature. Before the water molecules can start moving faster, which is all heat really is, a ton of energy has to be used up just to break all those hydrogen bonds first. And this is just huge for biology. It's the reason oceans and big lakes have such stable temperatures. They protect all the organisms living in them from wild, crazy temperature swings from day to night. It creates a safe and reliable place to live. Those hydrogen bonds also cause something called cohesion, which is just the tendency for water molecules to stick to each other. At the surface, where water meets the air, this cohesion creates a surprisingly strong film that we call surface tension. It's almost like a thin, invisible skin right on top of the water. And of course, life takes full advantage. It's how little insects like pond skaters can literally walk on water without sinking. And that same stickiness, that cohesion, is what helps pull water all the way from the roots of a giant redwood tree to its very top leaves. And one last thing on stability, and this is pretty cool. Water is incompressible. You just can't squeeze it into a smaller space. And this isn't just some abstract fact. Spiders actually use this property. They pump fluid into their legs as a hydromic system to move them around. How amazing is that? Okay, that brings us to our final section, and maybe water's weirdest and most important superpower of them all. Let's talk about water's strangest trick. I mean, really think about it for a second. For almost any other substance on the planet, the solid version is denser than the liquid version, so it sinks, right? If you had a bucket of molten iron and dropped a solid chunk of iron in, it would sink straight to the bottom. But with water, ice floats. Why? And this slide illustrates the reason perfectly. In liquid water, all the molecules are jumbled up, they're moving all over the place, constantly breaking and reforming those hydrogen bonds. But as water freezes, the molecules slow way down, and those hydrogen bonds lock them into place. And this fixed crystalline structure actually pushes the molecules farther apart than they were in the liquid. And because it's now less dense, ice floats. And this is profoundly important. For one, it creates a whole habitat for animals like polar bears. But even more critically, that layer of floating ice acts like a blanket, insulating the liquid water underneath. It allows fish and all the other aquatic life to survive through the winter. If ice sank, lakes and oceans would freeze solid from the bottom up, and life as we know it would be impossible. So let's bring it all home. The power to dissolve anything, the ability to stabilize temperatures, the tension that lets insects walk on its surface, and that bizarre magical property of floating ice. Every single one of these life-giving superpowers comes from that one simple fact we started with, that tiny, uneven arrangement of electrons that makes water a polar molecule. It's really an incredible story, isn't it? A molecule made of just 3 atoms with a slight electrical imbalance is responsible for our entire world. Which really just leaves us with one final thought. If something this simple and fundamental holds such profound secrets, what other amazing wonders are just waiting to be discovered in the everyday chemistry that makes up our universe?